Hello, my people. Hope you're doing well today. As promised, I'm going to be creating some videos based upon tests that I've given in years past to give you sort of an idea as to how I assess these things in preparation for sitting down and taking your first quiz of summer trig. I will let you know basically this is a honors pre-cal test that I gave back in 2010 2011. Back then I actually put I put a couple of multiple choice questions on each test because then I wound up creating their midterm and their final exam with quite a few multiple choice questions to keep myself sane during the midst of the grading. And that's kind of the only reason. But we're going to go through them simply because they have some of the information that you're going to be responsible for the quiz that I've posted. Now, first one, we didn't actually go over this. It says the word radian is an abbreviation of what two words? Okay, radian is radius angle, right? Because it is an angle that is equal to, like, one radius in angle measurement is basically corresponds to one radius of arc length. Okay. Now, the second one is a little bit tricky because it says a trigonometric function does what exactly? And the first two ones, it says it turns a ratio into an angle measurement. And the second one says it turns an angle measurement into a ratio. Let's go ahead and zoom in just a bit more. Now, we know that that's what trig functions do, but then look down at C and it says it reveals the constant associated with the angle measurement. Okay, well, that's true, but it's vague. Okay, and that's why it's vagueness, like what constant and how is it associated with the angle measurement. And D, it turns a degree measurement into a radian measurement, and that's not true either. It's either A or B, because we talked about it as a translation, right? But you should know that trig, basically angle measurements, you basically apply the trig function to angle measurements to turn them into ratios of sides, and therefore B is the correct answer. Okay. Which of the following best defines coterminal? Angles that have the same tangent ratio, angles in standard position that have the same terminal side, a nonsensical word with no meaning, angles that have the same reference angles, or none of the above. And it's actually B, right? And we get coterminal angles by either adding or subtracting 2 pi, or if we're dealing with degrees, adding or subtracting 360. The period for trigonometric functions is 2 pi for all except, well, like I said when we had class the other day, I'm not so much worried about you understanding the period right now. In years past, I've introduced it because the book introduced it during these sections, but I find it's more helpful to talk about the period when we start constructing the graphs. So if you want to know, basically 2 pi as a period is for sine and its reciprocal, and cosine and its reciprocal. Pi is for tangent and cotangent, and that'll make a little more sense when we deal with that. Now, none of these say tangent and cotangent, so the answer is actually E, none of the above. It says all of the following trigonometric functions are odd except, okay, all of the trig functions are odd except, and we talked about this, it's actually cosine and its reciprocal secant. All right. Now, that gets us past the cute little, multiple choice questions. Let's go ahead and look at some of the procedural questions. This one says, determine 2 coterminal angles in radian measure, one positive, one negative, for the given angle. Be sure that your answer is given in the same units. Okay, so obviously I cut and pasted a little bit and forgot to forgot to get rid of that, because in the second sentence it says be sure that your answer is given in the same units in which the problem is posed, radians to radians, degrees to degrees. 3 pi over 7, if we want two coterminals, we need to add 2 pi, and we're just going to add it as, oh, why am I working in red? We're going to add it as 14 pi over 7, because that's equivalent to 2 pi, and it has the same denominator. And so we're going to get 17 pi over 7. And if we want one negative coterminal, we're going to subtract 2 pi in the form of 14 pi over 7 and get negative 11 pi over 7. And the same thing with 3 pi over 4, although this one ought to actually look a little bit more familiar because it is a unit circle value, whereas the last one was not. And you get 3 pi over 4 plus 8 pi over 4, wind up with 11 pi over 4, and this one, of course, is negative 5 pi over 4 when you subtract 2 pi in the form of 8 pi over 4. Now, dealing with degrees, it's exactly the same principle. It's just you're going to be adding 360 or subtracting 360. Now, when we add 360, the 200 and the 300 become 500. The 75 and the 60 become 135, so this becomes 635 degrees. When we subtract, we know that 360 is bigger, so it's going to be negative, but the difference between those is the 25 that it takes to get to 300, and then the 60 more it takes to get to 360, so negative 85 degrees. Now this one, again, is going to be a little bit easier since it is indeed a unit, or, well, all of them are unit circle values, but are they common unit circle values is kind of what I mean by that. And you add 360, subtract 360, negative 60 plus 360 gives you 300 degrees, and this, of course, gives you negative 420 degrees. That ought to be really, really straightforward, okay? It shouldn't really be all that big of a deal. And if you're looking for it to get harder, all you have to do is wait for chapter 5, okay? All you have to do is wait for the graphs, actually, especially if you're not all that keen on graphing. But let's go ahead and move on to the next one, which asks us to find both a supplement and a complement for the given angle, if possible. Now, what "if possible" means is if you're looking for a complement of an angle, that means that both angles have to add up to 90 degrees or pi over 2. If the angle is already larger than 90 degrees, it doesn't have a complement, okay? And so that winds up being the case here for 4 pi over 5. 4 pi over 5 is pi over 5 shy of pi radians, or 180 degrees. It's already in the second quadrant. And so in terms of our complement, we don't have one, but in terms of how much do I need to add to it in order to get to pi radians, a simple pi over 5 will do. Now this one right here, we need to basically figure out, in terms of the complement, what do I need to add to this in order to get pi over 2, okay? Well, the problem is that you're going to have to basically transform this into 2 pi over 14 in order to get the complement, because you're going to need it to reduce to this, because there's no one thing with a denominator of 7 that you can add to this in order to get pi over 2. But you can add 5 pi over 14 to make 7 pi over 14, right? And that's what the answer is for the complement. Now, if you're looking for the supplement, how do I get it to be just pi? Well, if you have 1 pi over 7, you add 6 pi over 7 to that, and you get 7 pi over 7, or pi. And there you go. Now, The degrees, since you're used to working with degrees, ought to actually be much, much easier. 17 degrees, and you need to add 13 to that in order to get to the complement, and then 13 and 90, or 103 degrees, to get to 180. If you're looking at 12, in order to get to the complement, you need to add 78 degrees, and then 90 more than that is going to be 168 degrees. And if you want to check your work, just go and do the sums and make sure they add up to 90 and 180. Okay, let's go ahead and look at conversion. First, we're going to convert some radians to degrees, and then we're going to convert some degrees to radians. Now remember, it is either pi over 180 degrees or 180 degrees over pi, and you choose which one it is based on what you need to cancel, right? That's just in terms of very practical concerns. If I want this to cancel, I know I need to be multiplying this by 180 and dividing it by pi, because usually my degree measurements don't have pi involved, okay? And so therefore the pi's go bye-bye, and you have to figure out what is 3/5 of 18. Well, 1/5 of 18 is going to be 36, okay? And so 5 goes into 180 36 times, and then you simply need to ask yourself, what is 3 times 36? Well, 3 times 30 is 90, 3 times 6 is 18. Together, those make 108 degrees. Now, when we go over here to negative 3 pi over 8, we're going to be multiplying by the same ratio, okay? Getting rid of pi again. And you simply need to ask yourself, how many times does 8 go into 180? Well, 8 going into 180 might actually be easier for some of y'all, because 8 is 2 cubed. And if you're dividing 8 into something, you're simply halving it 3 times. So half of 180 is 90. Half of 90 is 45, and oops, we have a problem there. So 8 doesn't actually go in evenly, but 4 does, okay? And so we get negative 3 times 45, and negative 3 times 45 is negative 135. Negative 135 halves degrees, okay? And I like improper fractions. I hate mixed numbers, and I don't particularly like decimals either, because decimals are basically, people like decimals because they like their calculator. If you just want to leave it like that, that's just fine. If you're curious about what that actually is, it's negative 67.5. Sorry, negative 67.5 degrees. Okay. Okay, well, that's easy enough. Let's go ahead and do it the other way. Let's multiply these by pi over 180 in terms of, in order to convert them to radians. Obviously, that 0 and that 0 cancel out, and that allows us to sort of see that both of them had a common factor of 10. And you get negative 11 pi over 18. Fantastic. Alrighty. The next one might be a little bit tricky. 405 degrees. Well, 405 degrees is a little bit out of the ordinary for us, unless we actually see it as 360 plus 45. So that's a full revolution, and then just another eighth of a revolution. So that's 1 1/8 revolution. That's half of a revolution. And so basically what you get is therefore they both have a common factor of 45. Okay? If you take 45 into this, it's going to go in 9 times. Into here, it's going to go in 4 times, and that is 9 pi over 4. Okay? I'm not so worried about whether you're really good with arithmetic. Hopefully you'll get better and better as I encourage you to, put your calculator away more and more. What I'm more interested in is whether you're understanding the concept of converting one to the other, and whether you feel comfortable with which one it is. The actual arithmetic is just details, right? So if I were grading this, I would actually, put more points on that than I would on that, okay? Because I put more emphasis on the concept and whether in your procedure I can see an understanding, a conceptual understanding of exactly what's going on. Okay. Let's go down to 18 and 19. Both of these, let me take a read and see whether it's actually better for us to move on or whether we want to look at these for a second. A point on the rim of a wheel has linear speed of 33 centimeters per second. Now remember, linear speed is arc length per speed, right? So remember that arc length was s, and that was r theta. And remember that v is equal to s over t, or r theta over t. And remember, omega was theta over t, which made a third version of the linear speed as v omega. Okay. Now, let's try and figure out from the information that has been given which one of those is going to be most helpful to us. The point on the rim of the wheel has a linear speed of 33 centimeters per second. So that right there is your v. If the radius of the wheel is 50 centimeters, so there's r, what is the angular speed of the wheel in radians per second? I have v, I have r, and I'm looking for omega, which means that I am going to, sorry, that's supposed to look like an r instead of another v. Basically, I'm looking at this equation, specifically that form, okay? And what I need to do is, if I'm looking for omega, then omega is just v over r, and omega in this case is 33 centimeters per second over 50 centimeters. And you can basically reduce that just fine. And basically what you get is you're going to get 33 over 50 radians per second. Remember, radians sort of passes in and out of existence as a unit because it really kind of isn't a real unit, okay? Now, if you go ahead and pop it into your calculator, you're going to get 33 over 50 is 0.66, and the best approximation is A right there, radians per second. Let's go and look at 19. Oh, that's one of those latitude ones. Y'all admittedly struggled with that because you didn't understand latitude. I explained it, but let's go ahead and skip over that one, and let's move on to some of the 4-3 and 4-4 stuff, the right triangle trigonometry. Alrighty. The terminal side of an angle passes through the point 4, -3. Now, the first thing that you need to be thinking to yourself is, where is 4-3? Well, 4-3 is 1, 2, 3, 4, 1, 2, 3, down here in the fourth quadrant, right? And if I create a triangle and I'm looking at this reference angle right here, I can easily find, so that's 4, that's -3. I'm going to go ahead and just shock you right here. That means that's a 3, 4, 5 right triangle. And from there, I ought to be able to piece together all of my trig ratios. You have sine, which is opposite over hypotenuse, and cosecant, which is its reciprocal. Cosine is adjacent over hypotenuse, and secant is its reciprocal. And tangent is opposite over adjacent, and cotangent is its reciprocal. Okay? And so no matter what angle you're actually talking about, whether this angle right here represents the true angle or simply the reference angle for the infinite number of coterminals that has this as its terminal side, it doesn't matter, okay? No matter what theta, the actual theta is, this reference angle, that triangle, as it extends down into the fourth quadrant based upon reference angle theta prime, will give you these ratios every single time. All right, let's go ahead and move on to 22. Let me zoom in again. All right, sine theta is equal to 5 over 13. Now, we know that sine is opposite over hypotenuse. Now, the hypotenuse is always positive, and so basically we need to figure out where the opposite side is positive. And of course, when you're dealing with reference angles, the opposite side is always the vertical displacement. So we're talking about y, and that should make sense because, as you've been taught, sine theta is associated with y anyway. So in what quadrants is y positive? Well, in the first and the second quadrant, okay? But in only one of those two quadrants is cotangent negative, okay? Cotangent is everything's positive in the first quadrant, so obviously this is going to basically say, psst, by the way, that sine ratio is in the second quadrant. Let's go ahead and draw it. I'm going to try to draw it a little bit to scale, but may not succeed. Okay, we're going to have, 1, 2, 3, 4, 5. And then, of course, if this is 5 and the hypotenuse is 13, this is a 5, 12, 13. 1, 2, 3, 4, 5, 7, 8, 9, 10, 11, 12. And basically, this is as close to scale as I can freehand right now. Okay, and that right there is going to drop down, create our right triangle with our reference angle, theta prime, okay? So no matter what the actual theta measurement is, whether it just happens to be, whether that is theta or whether, that is theta or one of its coterminals, all coterminals that result in this theta prime give you this triangle and give you the same ratios. Now, we're already familiar with what sine is. It was given, right? And you might as well have just given me cosecant as well, because all I have to do is flip it over. So if that's 5 and that's 13, second quadrant, I know that x is going to be negative. So it's 5, 12, 13 right triangle, but that's a negative 12 because on the Cartesian plane, left of the y-axis in the second quadrant, my x measurement is going to be negative. Now that means that I have negative 12 thirteenths for cosine and negative 13 twelfths for secant, and I have negative 5 twelfths and negative 12 fifths for cotangent. Okay. Now, let's go ahead and move down to 23. I see, and this is a little bit different because the last one started with sine and cosine, and we're used to sine and cosine representing unit circle ordered pairs, and we know where they're positive and negative, but sometimes we have to stop and think for a second about where tangent is negative. Well, tangent is negative where sine and cosine have opposite signs, S-I-G-N, okay? And sine and cosine one is positive and the other is negative in the second and the fourth quadrant, okay? Okay, so this right here gives me second or fourth quadrant. That's what that tells me. Sine being negative tells me that I'm in the third or the fourth quadrant. Now, which one do both of those have in common? Obviously, fourth quadrant. So that's where we're going to draw it. Try and draw it pretty well here. Now, opposite, of course, is going to be, if you have a triangle right here in the fourth quadrant, actually let's not really worry about it being to scale. Let's just worry about reasoning it out, okay? Because we just need it to be a placeholder, right, where we can basically put our quantities down in order to read those quantities back off of the triangle. I know that this right here is opposite of theta, so it's going to be 6. Well, but see, it's extending down, so I know that it's the negative. and this extends to the right. That's positive x, so it's 7. Now I simply have to get the hypotenuse. Well, 7 squared is 49. Okay? 6 squared is 36. And that's going to wind up being 85. So this is going to be root 85. Which is a little bit more than 9, right? Because square root of 81 would be 9. Square root of 85 is, less than a quarter way to 100. So it's probably, 9.2 or something like that, okay? Which makes sense because as the hypotenuse, it should be larger than both legs, and it indeed is. We know that the way that the problem is given to us, we already have tangent and cotangent. I cannot tell you the number of times as a pre-cal teacher that I've actually had people give me a different answer here than was given here because they read it off of their triangle wrong. Basically, this should be read from here lest you make a mistake, okay? Now let's go ahead and just read the rest of them off of here. It's going to be opposite over hypotenuse and hypotenuse over opposite. And this is going to be adjacent over hypotenuse and hypotenuse over adjacent. Now, I have a very little room right in here, so I'm not going to rationalize those denominators, though you know how to. And I'm hoping that this, and of course I have 2 more tests that I'm gonna go over between on the second and the third video, and I'm hoping that as based upon your homework, based upon the time that we spent in class doing it, based upon the videos that are specifically on these 2 sections, that we'll have a really firm grasp and familiarity with these concepts before we venture into the deep waters of trig graphs and inverse trig and then analytic trig in the next chapter and fun stuff like that. But basically having that trig instinct down really cold is pretty important. Okay. Application problem. Let's go ahead and take a look at this. From the top of a 100-foot building, a man observes a car moving toward him. If the angle of depression of the car changes from 14 degrees to 34 degrees during the period of observation, how far does the car travel? Okay, well, let's just draw a pretty picture. I am not an artist, by the way, so you are not allowed to laugh. Boom. Okay, and he's going like this, and here's your guy up here. And if any of you know my daughter and you're like, yeah, she's a pretty good artist, yeah, and I have no idea where she got it from. Okay, and of course this is not to scale, so let's be sure about that. And so basically there's a starting and an ending point for the car based upon this guy's observation. Now, in that first one, we're talking about the angle of depression, which basically extends from that line that extends out parallel to the ground. If he were looking straight out, parallel with the horizontal ground, he would have an angle of depression in terms of his eyesight of 0. But when he first sees the car, that angle of depression is 14 degrees, and when he's finished observing the car, it's 34 degrees. Well, I'm pretty sure you know a little bit of geometry, okay? Now, this right here, as it says, is 100 feet. This right here and this right here are parallel lines, and both of those lines, which represent line of sight, are transversals that cut those parallel lines. So these are alternate interior angles, okay? And what we need to do is we need to use trigonometry in order to find this distance and that distance, and then of course this distance right here, the one that I'm being asked for, is simply the difference between them. Now, I have opposite, this is adjacent, So basically it's going to be tangent of 14 degrees is equal to the opposite, okay, over the adjacent. And we'll call this x and we'll call this y, just for lack of anything better to call them. And that's going to be x, and therefore x is equal to 100 feet over tangent of 14 degrees. We also know that tangent of 34 degrees is 100 feet, because 100 is the opposite from this 34 right here, over the adjacent, which is y. And so y is equal to 100 feet over tangent of 34. So what I'm really looking for is x minus y, and that's 100 feet over tangent of 14 minus 100 feet over tangent of 34 degrees, okay? Or, you know, if you really want to, you can basically factor this out, so you only have to plug in the 100 degrees into your calculator once. However it is that you want to do it, I really don't care. Okay, we have 100. Notice that I'm already in degree mode. Okay, that is very, very important. Tangent of 14 minus, and we're going to go ahead and do another ratio, 100 over tangent of 34 degrees, and boom, 252. Now remember, we always are going to be estimating to 3 decimal points, 252.822, okay, feet. And then, of course, as I said in the lecture, if it is asked in sentence form, I do need you to answer it in sentence form. And just as simple as the car traveled 253 feet, or, you know, approximately 253 feet during his observation, or however you want to term it, okay? Now, I hope that's pretty clear in terms of how to work that. Some of these are a little bit more difficult, and none of the trigonometry is difficult per se. Most of the difficulty with word problems is the translating, right? Basically mining the question stem for the information that you need. Okay, well that brings us to the end of this. Oh, by the way, it was sort of a joke that I had with my former students. I used to give them a word of the day, and the extra credit was some of those words, largely because I was trying to shame them into learning their vocab because their vocabulary was terrible. But I just wanted to help make sense out of what that extra credit was all about. Basically, we're going to run through another test, which was from 2011 to 2012 in video 2. And video 3, we will do one for the year after that. So, if you have any questions, guys, be sure that you are making a note as to which video it's from, which video your question is from, and then just shoot me a message in Teams or shoot me an email. Bye.